So we're going to be working through the factoring part of our worksheet. And so I'll show the work for each of these. The first one here is a trinomial. And before we do anything, we always check to see if there happens to be a factor that can divide out of everything. And there can't. We also notice that there is a 1 as the leading coefficient. And so we are just going to be asking ourselves instead what multiplies to be negative 56 and at the same time adds to be negative 1. So of course we're looking for numbers that are very close together, and so I believe it's 7 times 8 is 56, and then of course one of them has to be negative in order to make a negative 1. So in that case I'm going to be thinking of the numbers negative 8 and positive 7. And so those are the two values that will make up our factors. And so that is the factored form of x squared minus x minus 56. The next one, again, looking for a GCF, or a greatest common factor, to divide out of everything, and we don't have one. And so then we're asking what multiplies to be 90, and then at the same time adds to be 19. The only two numbers that do that are going to be 10 and 9. And then our variable this time is an m, but don't worry if you forgot and put an x, it's all good. Alright, the next one here, again, we're trying to multiply to be negative 48 and add to be negative 1, or negative 2. And so thinking of numbers that multiply to be 48 and that are about 2 away from each other is going to be 8 and 6. And then we want to have a negative 2, so the larger one, 8, is going to need to be negative. And so in that case we will have m minus 8 and then also plus 6. Alright, continuing on, same idea. We're trying to find what multiplies to be 30, but then at the same time would add to be negative 11. Two numbers that come to mind that make up 11 are 5 and 6, and then those also multiply to be 30. Notice that we want to multiply to be a positive 30, but somehow add to be two negative numbers. And so in that case, negative 6 and negative 5 are what we're looking for, and we're having x as our variable here. Alright, the next piece here, again trying to find out what multiplies to be, in this case, a factor of the first and the last. So the 5 times 16 is going to make up 80. And so we're trying to find factors of 80 that add to be 42. And so very simply, 40 and 2 multiply to be 80. And so there are two ways that we can go about this. We can either do the box or we can do factoring by grouping. Factoring by grouping tends to be curious for some people, so I'm actually going to do factoring by grouping to make sure that we kind of know how it works. So 5n squared, but this middle term 42n is going to turn into a 40n and a 2n that we will add 16 to. So that entire term in the middle becomes two different terms, and now we can factor by grouping, meaning we group each piece and divide out the greatest common factor within them. So 5n squared and 40n, there's definitely a 5 and an n that can come out of both of those, which means that we will be left with, let's see, I'll write it on another piece of paper. We'll be left with 5n, and then the leftovers of 5n, n plus 8. And then to that we have 2n and 6 that we can take a 2 out of. And so we're left with an n and, oh, that's a 16. So we're left with an n plus 8. Hopefully you notice that both of them have an n plus 8, and so that's going to come out front, and then the leftovers of 5n and positive 2 means that this is the set of factors that multiplies in number 5 to get to 5n squared plus 4n plus 16, which now I'm realizing, oh, I do have n's. Yay. All right. The next one is the same idea. Again, first checking to see if there's anything that can divide out of all of them, which I guess technically a negative, so we may as well do that because taking out as many negatives is always as helpful as possible. So if we take out a negative 1, we're going to be left with positive 5n squared plus 46n plus, minus 46n plus 9. And then we're going to try to find out what multiplies to be 9 times 5, so what multiplies to be 45. But then adds to negative 46. So the only things that are going to work there is going to be negative 45 and negative 1 to multiply to be a positive 45, but then also add to be a negative 46. So officially in number 6, we have a negative 1 way out front, and then if we take the time to rewrite, let's see, 5n squared, and then our middle term is now going to become 45, negative 45n, and negative 1n, and then that last term of positive 9. So factoring by grouping, means that we could divide out, at least a 5 and an n to both of these. So still negative 1 way out front, but now we have a 5n. That will leave an n, and minus 9. 9 times 5, yeah. Hopefully, when we take out the next piece, we will also get an n minus 9, and if we look at it, how are we going to make an n and a negative 9? We're going to take out a negative 1 from both pieces. So if we take out a negative 1 from both pieces, we're left with a positive n minus 9. Alright, so officially that means that this piece has been repeated, and so we can take it out front. And then our leftovers are 5n minus 1. And then, of course, the negative 1 way out front. All right, moving on to number 7, we have a binomial. So, again, still looking for your greatest common factor every time. Looks like 6 can divide out of both of these, and then also x. So out front is 6x, and then our leftovers are 18 divided by 3, which is, 6, which is 3, an x left over. And then 30 divided by 6 is 5 with no x's left. So that is completely factored there. Wow, the next one has a lot of x's, so at least to trim it up a little bit, we're at least going to divide everything by x squared. After that, I don't really see any numbers that could divide into each of these, especially since 2 and 5 don't go into 63 and they're both prime. So kind of like the problem in number 6, we're going to have this x squared that's way out front, and then the leftovers of negative 2x squared plus 5x after we take away 2 and x squared, and then plus 63. And so now again, since there is a negative 2 out front instead of just a 1, we're going to find what multiplies to be 100 and, what's 63 times 2? So we're multiplying to be negative 126, and then adding at the same time to be a 5, which sounds like it might not work, but we are going to have a negative involved, so we can get down to a 5. So let's see. In number 7, we're looking for the factors of negative 126. And so, of course, there's 1 and 126, but none of those combos is going to make a 5. There's also 2 and a 63, which is what we just did to get that number. Let's see, 126 divided by 3 leaves you with 42. Again, no combo is going to make 5 there. 126 divided by 4 does not work, at least for a whole number. 126 divided by 6 is 21, so we have a 6 and a 21 option. Again, not getting 5 from that. Let's see, there's 7 and 18, but that'll make 11 if we subtract, so that's not there yet. 8, nope. 9, yes. So it looks like 9 and 14. Because if we want to get to a positive 5, to multiply these two numbers, we're going to have a positive 14 and a negative 9, and those two will add to be 5. So if we take the time to rewrite the original equation, of course now we have an x squared way out front, but we have negative 2x squared, and then our new pieces of negative 9x and positive 14x, and then the last piece of plus 63. That means that we can factor by grouping, so we group this set and find out what we can factor out. Let's see, in this first piece, a negative and an x. So we'll be left with negative x out front, and then the leftovers of 2x plus 9. The next piece is going to have, let's see, 7 that can factor out of both of these. And so we'll have plus 7, and then the leftovers of 2x plus 9, which of course matches. So now we can keep that x squared out front. Oops. Factor out the black 2x plus 9. And then have our leftovers of the green x and the 7. And so this is the full factored version of number 7. Oh, and by number 7 I mean number 8. Okay. So then number 9 has a trinomial again. Looks like we'll probably be able to factor something out initially from each of these. Let's see, 183, what is that divisible by? So it looks like only a 3 is going to come out of each of these pieces. If you want, you can do a negative 3, and in fact I do, because I like to take the negatives out as soon as possible. So negative 3 is going to be out front, and then we're left with a positive 10n squared plus 60, oh wait, we're doing a negative, so let's take away that. It's negative, because we're dividing by a negative. Negative 61n, and then plus 6. So same thing as what we did before. We're trying to find what multiplies to be 60. And then at the same time adds to negative 61. So really not that hard to figure out. It's 60 and 1. So let's rewrite this. Let's see, we have our x. Oh wait, we have the negative 3 out front. And then a 10n squared and a 6. And then the two pieces that we just found are that it's going to be negative 60 and negative 1 that will multiply to be positive 60 and at the same time add to be negative 61. So negative 60 and negative 1. Then we'll go through and factor by grouping. So this first piece we can take out a 10n. and then the leftovers are just an n and 6. Again, hopefully that's the same for this next one. So if I want to make this n minus 6, I'm going to need to take out a negative 1. And then the leftovers are n minus 6 again, which means that ultimately we'll have a negative 3, but also n minus 6 from both of these, and then the leftovers of 10n minus 1. It's like a little puzzle. Woohoo! Alright, moving on to number 10. Same thing here. We have something that's other than 1 out front. Let's see, 71 is divisible by... turns out by not much. I think it's prime. So we're just going to go through and multiply. And so we're trying to find out what multiplies to be 9 times 90. Yikes. 810. And at the same time adds to be 71. So factors of 810 are not well known. And we're trying to get to 71. So let's see. And so it looks like after, again, going through the entire list that we can actually go with 81 and 10 that multiply to be, if we want negative 810, one of them will have to be negative, and that would be the negative 10. So if we go through and rewrite this, we're going to have negative 9x squared, but then we're going to have a positive 81 x, and then a negative 10x, and then a positive 90 that we can do our grouping with. So moving on to grouping, if we take this first piece, definitely a 9 can come out of both of those, and an x. Since I like to get our negatives out as much as possible, let's do negative 9. So if we do negative 9x out front, the leftovers after that is going to be just an x and then a 9. Taking a look at our next piece, a negative 10 can come out of both of those. And then you're left with an x plus 9, which means the x plus 9 is out front, and our leftovers are negative 9x minus 10. The answer key may in fact have a negative way out front, x plus 9, 9x plus 10. So either is fine. It's just those negatives that they'll sometimes weave into there, make it feel like it's a different answer, but it's not. Alright. Moving on to number 11, definitely a binomial, so we're just looking for a GCF to begin with. 8 and n can divide into both of those, and so 8n comes out front, and we're left with 2 from 16 divided by 8, n from n squared divided by n, and then a 1 for 8n over 8n. Alright, our last example here, looking for something that might divide into each of these. Looks like all of them are divisible by a 6. Whoops. And because of the whole negative thing, I'm just going to take out a negative 6 as well. So negative 6 out front leaves you with positive 6b squared. Ooh, yeah, my 6's and b's look the same. Plus, let's see, 114 divided by 6 is 19b. Oh, and by plus I mean minus, because we're doing positive divided by a negative. And then the last piece is negative over negative, so 90 divided by 6 leaves us with positive 15. Alright, so now we get to figure out what is going to multiply to be 90. And then add at the same time to negative 19. A lot of these aren't very special. They're just the 9 times 10 in this case, just like the previous one was times 10 as well in number 10. So going ahead and rewriting number 12 so that we have more room to solve. and deciding that our two pieces are negative 10 and negative 9. So we've got negative 10b that should go in for negative 19b and negative 9b. And now we're going to factor by grouping. So out of this first group, they're both even, so a 2, and they both have a b, so we can divide that out. So negative 6 still out front, and 2b. And the leftovers of 3b minus 5. Then to that, we're going to divide the next piece by a negative 3, because if we want it to match here to this guy up here, you need to have a positive first. So let's see, we're going to have negative 3 out front, and then the leftovers of 3b minus 5. And so finally our factored version has negative 6, the 3b minus 5 from both of them divided out, and then the 2b minus 3. There it is. So that's lots of factoring, and hopefully you kind of went through what we had in our notes on doing a GCF first, after the GCF, then doing, is it a difference of squares or cubes, if it's a binomial, and then if it's a trinomial, if you either have to multiply the first and the last digit, which if it's 1 anyway, you always do, or if it's a 4-term polynomial, you got to do factor by grouping. Sweet.